Welcome, students. So today, what we'll be looking into is a problem from electrostatics. It's just an advanced version of what we are aware of already. That is about what is the electric field for a thin sheet of infinite length and breadth. So we are all aware of that, which is like sigma by 2 epsilon naught for in a free space. Uh, but what happens when we actually bring in two such sheets together, very close to each other, something in proximity, some very similar to what happens with the capacitor, where we have two conducting plates. And here we have two cases that we'll talk about, which is actually when the plates have the same polarity for A and B, and what happens when we have the opposite polarity, which is again positive and negative. And sigma A and sigma B are being provided as the surface charge densities for both the plates. So we are all aware that if there is a positive charge of thin sheet, then the electric field actually is applied in this direction. What happens for B? Again, because it's positive charge, so we can say EB here. So EA and EB are like this. So what we want to determine is actually what is the net electric field outside of these two plates and what is the net electric field inside. So let's take for the case when it's inside. So E in we can say is equal to both are in opposite directions. So EA minus EB. Okay. And putting in the value directly, what we have is like sigma by 2 epsilon naught, which is sigma A minus sigma A B by 2 epsilon. Okay. And the net that we'll get is 1 by 2 epsilon naught sigma A minus sigma B. What happens outside? If you look into it, outside also, because of this right hand side, which is the B plate, we will outside, we will again have an additional EB here. And outside here, because of this plate, we will again have an EA. So the net will become actually the summation of these two, both actually propagating outside. So the E out will become EA plus EB, which actually finally comes out to be 2 epsilon naught sigma A plus sigma B. Okay. The interesting thing here is if you look into it, what happens if both sigma A and sigma B are same? For example, if you put a charge which is like Q and the area is same, so sigma A becomes equal to sigma B. So in this case, E inside becomes zero, which is a very interesting case that will not have any electric field inside these two plates. Okay. But whereas this one will be something like sigma A by epsilon or epsilon naught. Okay. So these two will actually sum up to be the same. So it becomes 2 sigma and 1 by 2 cancels out. So it becomes sigma by epsilon. Now coming to the second scenario. Second scenario when we have two, we have the opposite polarity. Okay. So in this case, we have which is EA, similar to what we have earlier. And for this EB, the direction is now is opposite towards the plate. Okay. And for from A, what happens after B is actually this continuation of this EA, which is like this. And again, because this again is negative charge, so this becomes EB. The electric field, when we actually sum up for inside and outside, it becomes E in is equal to EA minus EB, sorry, plus EB, which is equal to again, that is sigma A plus sigma B by 2 epsilon. Okay. And what happens outside? Because these are actually kind of whatever direction you want to take. So you can put a mod here and say sigma A minus sigma B by 2 epsilon. Whichever is actually the higher value, and you can decide on the direction later. Now, if you look into this, what happens when the charges actually are same or the surface charge density is same? You will see that E inside is actually becomes sigma by epsilon naught and E outside becomes zero, which is exactly the opposite of what we got from case one. Okay. So there could be multiple such scenarios where we can create, like we can put another plate and see what exactly happens. We can have multiple plates here and we can create some kind of complicated problems with this concept. Thank you.